Hi everybody. Okay, today I want to talk very briefly about solving linear equations. Okay, it just seems to be the case that a lot of times you solve more complicated equations, and that seems to be okay. We can do a lot of the interesting things with quadratics, even sinusoidal logarithmic equations. We can manipulate a lot of that, but then when we've reduced some of those equations down to just simple linear equations, that's where I see a lot of people make mistakes. Okay, the trick to understanding the way algebra works is to recognize that it really is just arithmetic with unknowns. If you understand arithmetic, really you should get algebra. Okay, because they are really the same thing. And just to illustrate this, I just want to take a look at a simple linear equation here. Let's say that we've got 3x plus 2, and let's say that that's equal to 17. Okay? Now we're gonna solve this here. I'm gonna solve for x here, but I'm gonna give you the answer right now, and I want to talk about how this works here. Because where some people get confused by this, we are not confused if we just took a look at numbers. So I'm just going to drop a little line here. I'm going to tell you that the answer to this is in fact 5. And what I want to do is I'm going to take a quick look at what happens over here and compare it to what goes on over here. Okay. Now, over here, you think about order of operations. 3 times 5, okay, is equal to 15. Plus 2 creates 17. Okay, so the left side here is equal to the right hand side. Okay, so that's a true statement over here. Now here we are going to assume that this is true. When we see an equal sign like this, especially with an unknown there, our assumption is that the left side and the right side are in fact equal. We just don't know what that value of x is that makes them equal. Okay, so what we want to do here, okay, is isolate the x, or get the x by itself, manipulate the equation, but making sure it stays an equation. Okay, we don't want to do anything to ruin that equality. We want to know what x is equal to. Well, the only way that we can figure out what x is equal to is if this remains an equality all the way down here. Now I'm going to do the work here, but I'm going to compare it to over here so that you understand what we're doing. Now in this case right here, I've got 2 terms on the left-hand side. I don't want that. I only want the term with the unknown in it, with the variable in it. Okay? Now notice that this can't be simplified any further, by the way. I can't go 3x plus 2, okay? Because you think about what's going on over here. In order to figure out what this is, I would have to go 3 times 5 first, then add 2. That's why this is 17. 3 times I don't know plus 2, well, I don't know. It's not 3 plus 2 times x. It's not 5x. Okay, I'm stuck here. A lot of times people don't know when to stop simplifying. Okay, and I've had this discussion with my students before. I call this Forrest Gump syndrome. Okay, if you think about how Forrest Gump plays football, he doesn't know when to stop. A lot of times that's kind of how we approach math. We don't know when to stop. Well, here would be a place, if I was trying to simplify this, I would stop here. 3 times x, I don't know what that is, but multiplication would have to come before addition. So I stop here. Now anyway, back to what we're doing with this. I've got 2 terms here. Only one of them has the unknown in it. I would like that term by itself on the left-hand side. I need to remove that plus 2. Now, I know what people think when they see this. I know what some people think. They see a plus 2 here. They want to put a plus 2 on that other side there to balance out both sides of the equation. But the mistake there is thinking that these two aren't equal right now. They are equal. Okay, I've got a plus 2 that I'm seeing here. I have to understand that somewhere in there is already a plus 2. Okay, that is mirrored on that other side there. This is an equality right now. Okay, it's not like this is missing a plus 2. No, they are equal. So how do I eliminate a plus 2 from that left-hand side? Okay, that's got to be your goal. Don't think about trying to balance it on that other side. No. Your goal here is to get rid of the second term here, and I do that by subtracting the 2 from both sides. Now, it would be nice, I mean, as a teacher, it would be nice if we could get to a point here where you don't have to write that down, this -2, -2. You just understand, I got to subtract 2 from both sides. But in this case here, if I take and subtract the 2 from this side, I'm just going to be left with 3x. And on this side right here, I'm going to be left with 15. Now over here, see this, it makes a little bit more sense here. This is 17, okay, is equal to 17. I don't gain anything by adding a 2 to that side of the equation. If I add 2 to that 17, I would get 19. In which case, those two are not the same, okay? I'm just trying to stop people from doing this by adding 2, because I see that happen a lot, where they see that plus 2 there and they just want to add 2 to that other side there, but that's incorrect. Okay, you are not maintaining the equality there. So I would not, in fact, add 2 to this side. What I'm trying to do here is if I subtract 2 from this side, subtract 2 from this side, I'm going to get, 3 times 5 is equal to 15. And again, I can see that that's true. Over here, now I've got, on the left-hand side, because it's a single term equal to 15, now what I got to do is I got to break this apart in terms of factors. Up here, there were 2 terms. I needed to get rid of one of the terms. Well, I do that by using addition or subtraction. Once I get it down to a single term, now I got to look at it and consider it as factors. I have 2 factors here. 3 times x is equal to 15. Okay? So, I mean, there are a couple of ways I can think about this, but really what I want to do here is I want to remove that factor of 3 from there. Now, there's multiplication. Okay, it's 3 times x. Don't make the mistake of thinking, well, there's a multiple of 3 here. I have to multiply that side by 3. No. There's already a factor of 3 here. There's already a factor of 3 here. Now what I want to do is I want to strip that part away so that I'm just left with the x. And to do that, to get rid of this 3, I'm going to divide by 3 on both sides. Remember, this is an equality. Okay, so whatever I do to the left side, I got to do the right side to maintain equality. But the assumption is that they were already equal. Okay, so 3 divided by 3 gets me 1. 1 times x is x. 15 divided by 3 is 5. And I've solved this. I get that x is equal to 5. Over here, I say the same sort of thing here. 3 times 5 is 15. Yes, well, of course it is. And if I divide both sides here by 3, okay, I get 5 is equal to 5, which is a true statement. Okay. So here, 17 equals 17, 15 equals 15, 5 equals 5. All the way down, that is equal, which means, and I did the exact same thing over here that I did over here, so all the way down, these are equal all the way through every step here, and so I can get here that x is equal to 5. One other thing I want to comment about this is one of the things that I see happening from here to here, and I see this happen an awful lot, okay? The mistake in thinking when we get it down to this part right here, I often see people do this. 3x is equal to 15. And so what they do is they divide both sides, and I end up getting that quite a bit. Okay? Because what you're doing is you're dividing both sides by 15. Now, actually, it's a question like this, I shouldn't say it this way. In this question right here, that probably wouldn't be the mistake here. This is where that kind of mistake happens a lot. If you reduce down a linear equation to something like, let's say like this here. Let's say that you get 6x is equal to 3. Okay? Well, I've got term equal term. Okay? So this is really just breaking it apart now in terms of factors. I want to strip away the factor of 6 from both sides. But because, because there's a general, let's say, reluctance to work with fractions here, a lot of times what I'll see people do is, oh, 6 times equals 3. That's got to be 2. It's got to be 2, right? Because instead of dividing both sides by 6, like you're supposed to, remember I want to strip away that fraction, so that factor there, and get 3 over 6 or 1/2. The reluctance to work with fractions, I'll see people do this quite a bit, and actually what they'll end up doing is dividing both sides. Well, I think in their heads they're thinking they're dividing by 6, but the reality is what they end up doing is dividing by 3, and then telling me that 3 over 3 has got to be 2. Okay, because they're seeing that 6 over 3 is 2. They know there's a 2 in there, and they'd rather work with that than fraction. Well, that doesn't make any sense at all, because 6 times 2 is 12. It's not equal to 3. You're not maintaining equality there when you do that. Okay, so remember, when you get it down to this form right here, when it's term equal to term, and I'm stripping away the extra factors here, okay, it doesn't matter that this number is bigger than that one. Okay, it just means you're going to get a fraction as a result. There's nothing wrong with fractions. Nothing at all. Now, I hope that helps, but I suspect that, once again, this is a math monologue and nobody's listening.